So this video is going to be about atoms and isotopes, and the goal of this video is to know how many electrons can fit in each energy shell, be able to draw Lewis dot diagrams of elements, know how to write in standard atomic notation, and be able to distinguish between isotopes and radioisotopes. So the atom. The atom is made of subatomic particles, so protons, which are positive, neutrons, which are neutral, and they're located in the nucleus, and electrons, which are negative, in energy levels. So we can use 2n squared, where n is the number of the shell, and we can determine how many electrons can fit in each shell. To determine these are your valence electrons. So our first shell can hold 2 electrons, our second shell can hold 8 electrons, and our third ring, which would be able to hold out 18 electrons. When a shell contains the maximum number of electrons, it is said to be filled and stable. Electrons in the outer shell of an atom are called valence electrons, and the shell is called the valence shell. So Lewis dot diagrams notation involves the chemical symbol of an element with valence electrons, which are represented by dots surrounding the symbol. The mass of an atom is determined by the number of protons and neutrons. The mass of an electron is negligible since it's so small. To find the number of neutrons, you subtract the atomic number from the mass number. So for lithium, if the atomic mass number is 7 and the atomic number is 3, the number of neutrons you would have is 4. Unlike protons, the number of neutrons in an element can be different. So we use the word isotopes, which are atoms that have the same number of protons but different numbers of neutrons, creating a different mass number for the same elements. So for example, for carbon, you know that the atomic number is equal to the mass number. So for carbon 12, it has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. And then carbon 14 has 6 protons and 8 neutrons. Radioisotopes. These are isotopes that have unstable nuclei that can decay or split into different stable isotopes and release some energy in the process. The process in which a nucleus splits into smaller parts is called nuclear fission. This happens when a neutron collides with a nucleus of radioactive elements such as uranium. And this is the nuclear reaction equation. The atomic mass of an element is given in atomic mass units, AMU or U. Most elements have at least 2 naturally occurring isotopes, therefore the average atomic mass is taken. So isotopic abundance is used to calculate average atomic mass. It's the amount of a given isotope of an element that exists in nature, expressed as a percentage of the total amount of this element. For example, copper 63, the isotopic abundance would be 69.2%, and for copper 65, the isotopic abundance would be 30.8%. So to calculate the average atomic mass for carbon, what we first have to do is we have to take carbon 12, and the exact weight is 12, and we're going to multiply it by the percent abundance, which is 98.90%, and then we're going to add that to the carbon 13, so the exact weight times its own percent abundance. Then we add the results together, and this is our average atomic mass for carbon, 12.011 AMU.